My name is Glenn Wu. I'm co-founder of R&B Technology Group. R&B is now a AI company that provides AI enterprise solution for different vertical sectors. And one of our major sector is for sure with smart cities, including smart buildings and renewable energy. And my background has been with building controls, energy modeling, and the data analytics. And since the founding of R&B, R&B has been transformed from a building automation company to a data analytics company. And since 2016, R&B has started embracing the techniques of AI. So today, I'm going to share with you guys the most frontier AI technology, which is causal relationship and its application in smart cities. And I also like to share with you our insights and experience with the smart city industry over the past couple of years. And during my presentation, please interrupt me anytime if you have any questions or comments to my slides or whatever I'm telling you. Okay, so now I'm started from the my deck. I will start from the data problem of today's smart city, and more specifically, I want to narrow our discussion into energy digitalization of a smart city, because smart city is a much broader concept, from energy digitalization to security to many kind of things. So if we narrow our discussion into energy side, so firstly, let's look at two typical applications in smart city, in energy sector of smart city. One is renewable energy, a 100 megawatt utility level PV plant, and a smart building. Actually, it is a commercial complex. So if we take a look at the data for these two applications, so we can see firstly there looks like a lot of data. Even for a PV plant, it may have 100K data points, and for a complex may have 56,000 data points. And so the first concept I want to mention, which actually I think I mentioned this a couple of years ago, it is time to transit from energy use intensity to data use intensity if we want to talk about energy in digitalization area. And now more and more people are talking about data insights. And we have seen many companies, big and small, who want to figure out insights out of data, but mostly operating data of a smart city system, either a PV plant or a smart building or something else. So secondly, I want to define a little bit about deep insights of data. I believe many of the audience will have some experience with systems like SCADA or building automation system. And in those kind of traditional system, we will see something like a threshold alarm that's been defined by a low limit, high limit of any measured data or sensor readings. But they are not good enough for a building or any asset to become smart. So I want to define the deep insights as patterns, rules, principles even knowledge and expertise that's usually provided by human experts. And eventually, even decisions can be made out of data in an automatic way. And I also want to particularly mention in the real life system, any process is highly linear, highly nonlinear, and even in the last slides, we may see the data volume is a little bit overwhelming, but in terms of AI and in eyes of AI, the data is still scarce, and then the high quality data of the real world system is even much scarcer. And for the business problem, the AI or data insights want to solve, I think simply said, it's dollar sign. We want to use the data insights to save costs, either energy costs or operation maintenance costs. And in some cases, we want to use the data insights to enhance our revenues, for example, in renewable energies that's being integrated with the grid. So next, I want to look at more complex application. I believe this chart is pretty familiar to many audience. A smart building integrated with PV, with EV charger, and today's energy storage is becoming increasingly hot and popular in the landscape of smart city. But if we really want to look at the real performance of a system like this, we still need to solve a couple of problems. Firstly, yes, as always, energy efficiency. We want to save the energy consumption of the building to have a reasonable or optimal sizing for power storage and the PV panels, the renewable energy, and more important, we want to adjust the demand in a response to either the load dynamics and the dynamics of the grid. And we may always want to have an optimal sequence to operate such a complex systems to make sure we achieved the goals of either economy and the reduction of carbon footprint. So that's why we need an AI that can work as a human expert in energy digitalization. And this AI is able to provide expertise, knowledge, and even decision-making as a human expert to different applications in the industry. So over the past years, we have been developing a human expert AI based on causal AI technology and the symbolic AI. And based on the generative AI, which is very hot today because of the typical, the most famous symbol of ChatGPT. So, but I want to focus more on the features of causal AI and the symbolic AI, and I don't think generative AI is a major solution or something we want to focus in the industry, because in the industry we need a professional engineers or experts how to operate or optimize an energy system. We don't need that badly say a writer for this industry. So causal AI means out of complex data set, the AI is able to establish causal relationship and discover causality and even make the causal inference for decision making out of the data. And the symbolic is what is actually a expert system that is able to abstract and store and learn knowledge, not from data, but just from human knowledge. And we make the two AI engine to work together and then make the joint decision making. And that's the closest. That's the best and the closest human expert that AI can make. So I will little bit explain the causality of data. So but this table is just a very small sampling of a data set from a PV system. I believe this structure is the same for any time series data that can be extracted from any SCADA system or building automation system. So we have like 7 or 8 columns that represents the data point. And we have multiple rows for data that's sampled at a different time step. And so if this data set is sufficient enough, the causal AI engine is able to establish or learn the principles of knowledge from this data set as something like this: weather data is the cause or has a causal relationship with current and the delta angle, which is the measurement of a tracker of a solar PV systems, and eventually it will cause the current output of the combiner and eventually the inverter. So these principles, in other words, the knowledge, can be extracted from a data set like this, in automatic way, and presented in a graphical way like this, with an arrow for causal direction. So the arrow indicates the cause and the consequence as a result of the cause. So we can see the change of solar zenith and azimuth causes a change of tracker current angle, and and the change of the delta angle will cause the current at the combiner and eventually the output of the PV plant. So this short video visualize how the causal relationship, how the one data impacts another, and in a quantitative way, has been established and learned from a structured data set, like in this example, which is a air handling unit with 7 data points from return air temperature to supply fan frequency. And this video visualize if we take a look at the big picture of a large commercial complex, and if we put all the data into a causal graph. And in this causal graph, AI is able to capture the abnormality and achieve the causal influence and detect the abnormality or fault like this, and present the inference path to human operators and engineers for further actions. And next, I will explain a little bit about symbolic AI. And not every AI is trained from data. And there is a very conventional and old AI technology called expert systems. There are so many knowledge and the rules in human world that's just been there and been taught to human experts through our educational experience from middle school to university. So we have developed a knowledge library that stores all the energy, the knowledge of energy systems, and we extract and abstract the specific domain knowledge from the knowledge base and turn them into a graphical structure that's similar to causal AI and to make the decision together. So from this slide, I'm going to share with you a couple of applications we believe there is plenty of opportunities of applying AI for energy digitalization. So they are digital assets management, power generation management, and the microgrid operation. So I will give a couple of examples in each of these applications. Here is a live is a case study of building assets management. So if we collect the historical data, say smart building campus, for all the operating data of these assets of HVAC systems, of general facilities, and the lights, compressors, even data center. And so with the help of AI, we are able to achieve even annual energy efficiency by 80%, just by analyzing data and generate actionable recommendations. So this is a typical example of how AI works for managing and diagnosing the building assets in a feature called automated fault detection or abnormality detection. So we can see over the causal relationship, the AI is able to infer from the abnormality decided by a abnormality score or probability to decide which is the root cause of all these detected abnormalities. In this particular case, the root cause is the supply temperature of at the heat exchanger, and it has it further causes the low temperature at air handling unit and the high position of air of valve of air, the hot water valve of handling unit and the fan speed, and it causes a low fan speed of the chilled water coil, a chilled water deck of the air handling unit. So in typical building control, this is a very common control sequence for a VAV systems. So out of the data, the AI is able to learn all these knowledge and the principles and make the decision by detecting the root cause. in an autonomous and in an automatic way. And the solar power generation is another example that will demonstrate the ability of AI. It's even better because it's directly enhanced the power output, and in other words, the income of the solar power plant. So for this 100 megawatt utility level PV plant, AI is able to enhance annual income by 3.5%. With typical features of identifying power loss, root cause, and the generation prediction. So again, let's look at a typical example of how AI identifies the power loss in the generation. And in this example, the root cause is decided as a dust on panel. And this is the inference path graph that indicates this is the root cause of the dust and how the dust impacts the current at the combiner, and as a result, the low current at the inverter, and eventually the active power. That's a direct measurement of the performance of a power plant of the inverter. So if we take a look at this microgrid application again, and I believe this is the basis for zero carbon emission, which is so fascinated by the industry. And if we want to solve the problem we mentioned previously, from energy efficiency to demand response to load resilience and to an optimal sequence. So we need a high performance AI models to model the load flexibility. And this AI model will be based on actual data that can be accurately model the real load and operation performance of the building, and it can be computed efficiently without huge computing power. And we particularly, I want to mention one observation is we need to quantitatively assess the demand response. So even in North America, the participation into a demand response program is pretty low. It could be like only something like 20% participation rate with attractive incentives such as a rebate. So that's also a problem we need to address because the major reason for users rejecting the participation is because they don't have any idea how the demand response impact their assets. In this application, their buildings. Yeah, if the utility company reduce the demand by say by 10%, so how is my building is impacted in terms of comfort, security, and the energy or demand performance. And then we need a battery models. I think there are a couple of good companies or startups that are doing battery analytics in the market. And finally, we need to model and make the decision on optimal performance for such a complex system. So this is based on, in next few slides, is based on a real project we have been working with Apple in the US. And all the data are from a real building in California. And this project is intentionally developed to address and answer these problems. So yeah, this is charging and discharging models for battery, which is on site of this building. And we developed the algorithm engine to integrate both the data model and the symbolic AI, the human knowledge. We always believe a good decision maker by AI for any specific industry will always need the machine learning, which is based on data, and a knowledge system, which is based on human knowledge. Okay, so firstly, I want to demonstrate the quantitative assessment of demand response. So firstly, by every 1 Fahrenheit adjustment of the set point of this room temperature on the room thermostat, how many demand we can save in the real life. And reversely, say for every 1 kilowatt in demand reduction, how much temperature increase we would expect in our indoor environment. And then we will also establish and incorporate knowledge as a decision constraints. So the thermal comfort is one of the constraints, obviously. We want to save energy. We want to achieve zero carbon footprint, but that's not at the price of the thermal comfort of the occupants. We still need to maintain and deliver a healthy and comfortable environment to occupants, and when we want to achieve zero carbon emission. So this decision-making constraints is very critical in the decision-making process. And on the other side, yes, we train the model based on historical data, and we use optimal algorithms when we set minimal energy cost or minimal carbon footprint as our optimization goal. So in this graph, we can compare and we can visualize how AI is different from original operation sequence. So I want to mention this period from I think it's from 11 a.m. to 12 p.m. So in this hour, the original operation is just to charge the battery, so we can see a peak in the energy, in the electricity cost, and the AI will suggest to sell electricity from solar directly to the grid. Because this blue line is the advice from the AI, and this red dotted line is original operation sequence. And overall, on that single day, conclusively, AI able to increase output by 31% to the grid. And that's equivalent to 32% increase in dollars from selling the electricity to the grid. So this again, this blue line is the original cost under original operation sequence, and the red one is optimize the cost curve advised by AI. Okay, so I think I'm close to the end of this presentation. I hope the timing is good for you. So before I end this presentation, I want to mention the challenges we have met of applying AI to the industry. Again, data. We haven't seen data availability is good enough for most of the smart buildings and renewable sites during our experience. Either many of the smart buildings has pretty crappy BMS systems that has little data, and they don't even use any database. And for many SCADA systems, they just generate low quality data, and there is not good enough data, even they have a database. Yeah, so we want to suggest this is as a data infrastructure to be used for any smart city projects. Firstly, we want to emphasize, please have a database, and please stop talking about smart if you don't have any data or database. And my last slides is to give a brief of what R&B is. We are a AI algorithm company, startup. We have developed the AI engine and the platform tools associated to engine for many years. And we apply AI to a couple of vertical applications, from smart buildings to renewable energies, and to manufacturing and even business intelligence. We have offices in Shanghai, Hong Kong, and Houston. And fortunately, R&B has been backed by reputable investors from Susquehanna to BP and the CLP. Okay, thank you guys. That's the end of my presentation. So I think next is the for Q&A.
Indeed. Thank you so much, Glenn. And I think you can stop the screen sharing now.
Okay.
Thank you. So if you don't mind, I would actually like to start where you kind of left off, which was the last slide where you briefly spoke about your company. Yeah. I would love to learn a little bit more about R&B Technology. So could you tell us a little bit more about, how your company came about, how long you have been around, and a little bit about the customers that you serve?
Yeah. Yeah. Thank you, Joanne. R&B was founded actually as a automation solution provider to smart buildings and factories. And back then, we were quite fascinated with supplying control solutions to buildings and the factories, mostly in China. And I think 7 years ago, back to 2014, and we were turning our resources and the focus from a conventional control solution or engineering solution to a data analytics solution. When we were in when we approached analytics back then, some analytics methodology, which are mostly rule-based. And so in the first generation of our product, actually it's a rule-based or expert system platform or software to for smart buildings. So that's the symbolic AI part of our product. But over the time, we have encountered the challenges I mentioned in the last part of the presentation. We found out in this industry, in buildings and most of smart city applications, we just don't have enough data, and we don't have enough manpowers to develop rules that has to be tailored from one building to another. Simply said, human knowledge or expert system cannot be scaled in either way. So we decide to turn to some pure data solution. So that's why from 2016, something like that, we decide to develop the machine learning model for our product and we hope we can generate insights out of the data to supplement or even to replace the expert systems for smart buildings and other applications. And yeah, so we also encountered the problem of data availability, and that's pretty a pain point of applying AI for so over the time we integrate the data engine, the data AI, and the knowledge AI, and to make them work together and make the decision jointly. And this is a great balance for any situation that you don't have enough data, and you may not have enough human knowledge. So the knowledge or patterns learned from data can be a good supplementary to human expert systems. And also my personal experience, I used to study energy modeling based on first principle, and I believe many audience today will be familiar with simulation tools like Energy Plus. And to my experience, I can say this first principle modeling is away from accurate. It's way less in the real applications if you want to calibrate your modeling results, if you want to compare the energy you modeled to the real energy performance of a real project. Okay, so I think that's the history and the story behind how R&B growth from the very beginning of the founding and to today, where we are, and today why we have this AI engine based on both data and human knowledge. And so our typical customer are in these different verticals, from smart buildings and manufacturing plants, and renewable energies, and we are also touching business intelligence, something like digital marketing, and so that's mostly based on non-time series data compared to the application of industrial applications. So I hope I answer your question, Joanne.
Yeah, I think that was a good start. Can you also share with us a little bit about the size of your company? I do understand you're a startup, but how many customers? I don't know if you can disclose revenues or stuff like that, and maybe latest valuation round, what your valuation was for your company. Anything that kind of gives our listeners a bit of an indication of how big you are and how far you have come so far.
Oh, yeah. Even though it's a little bit sensitive, Joanne, I think I can share or disclose as much as I can about the company. We are still a startup because to develop, it has taken us quite a couple of years to develop this AI product, especially from rule-based to this AI-based. And right now we have about 40 employees in 3 different offices, respectively in Shanghai, Hong Kong, and Houston. BP and the CLP are our strategic investors that led the last round by the end of 2019, right before the pandemic. And our last round valuation is something around $30 million US. And we are at the point of commercializing, beginning commercializing this AI product, because it has become mature and ready to commercialize over the past years. And we have acquired and complete pilots with a number of big enterprises especially in Hong Kong. We work with CLP as our exclusive partner in Hong Kong. So we have great pilot project like Hong Kong Airport, Hong Kong Science and Technology University, and a number of hospitals in a collaboration with HK Hospital Authority. And in the US, we are working with a number of sports venues, and one of them is the biggest sports venue developers to use our product, the R&B, which is trademarked in US, to their asset management applications. So we simply said that we have a mature product ready in place, and we have acquired big enterprises and have complete pilots with them, and we are at the beginning point of expand across these enterprise to achieve high growth in next couple of months. That's where we are, Joanne.
Thank you. And you mentioned the US, you mentioned also Hong Kong. What's the split roughly in terms of your customer base or your future market development efforts between the US and China?
Yes, I think so far, I think the majority percentage is still with China. I may forgot mention one one typical customer in renewable energies, which we are working with in mainland China. And over the time, we believe roughly it could be like 50-50 split between US and China in terms of sales.
Yeah, okay. So looking at your competitors, what is it that you have that is unique? Why should someone come to you and not to another provider?
Firstly, I still want to emphasize the cutting edge of this technology, the causal AI. And we are one of the few companies that has commercialized AI causality in real applications. Recently, I just came into an article that is based on interview with, I think, the vice president of University Columbia University, and that woman who also used to work for computer science in Carnegie Mellon. And according to the quotes of this interview, AI causality is the next, is the most frontier in AI industry, and it will be the next hottest topic or application in the industry. This is because causality is able to tell us in a much accurate way how data impact each other, how data and the system work on time series and the non-time series basis. And it has a unique technical advantage over other analytics methodology. Previously, say correlation, covariance. Causality is the more accurate way for AI to analyze data, and it is the closest way to imitate the thinking, how a human expert thinks about a problem.
Another question, which might be a little bit technical, but I am curious to know. So you have earlier in your presentation shared the big savings that your customers can achieve. If it is reduced energy costs, for example, or improved reduced costs for operation and what have you. So are you in a position to actually do apply a pricing model where you actually take a cut of the savings you achieve for your customers? Or do you have a pricing model which is much more towards delivering individual projects?
I think, firstly, we position R&B as a AI company. Our core product offer is the software, a analytics software driven by this AI engine. So in real life, we use this AI to generate insights and valuable recommendations for customer to take actions. It's up to customers' management and operation to execute these actions and fulfill the goals of saving eventually. So we don't position R&B as a project company. We want to develop a cutting edge and a great product, and then we want to sell this product, the AI engine, across different sectors.
Okay, I think that's crystal clear. So essentially, you offer a product, and the clients who buy it and make use of it, they will keep all the benefits from doing so. Okay. I also have another question to you. I mean, when you reflect on your own entrepreneurial journey and the company's history over the last few years, when was it that you realized that this is really going to work? Is it once you had a product that you felt a great confidence in, or was it when you found a particular financial backer, one of the investors you mentioned before, or was it even when you secured a big client? When was it that you felt for the first time, wow, this is really going to work? We are on a good, successful journey.
Yeah, well, yeah, so not particularly last 3 years, Joanne. So last 3 years is unforgettable, you know. But yes, along our journey, I think firstly, we were inspired by a number of customers and investors to start developing this product. So one of the inspiration we had is with a big enterprise customer in China, and one of their executives was asking us if you can monitor and assess the performance of facility management by telling me what's going on with my equipment and assets. So we came to believe this is a real demand needed by customers, real needs across different enterprises, and this is innovative and great because it's purely data driven. It doesn't involve any hardware or any heavy assets. This is simply said, this is something cool. So that's why we started this long journey of developing a analytics engine that's able to provide insights in an automatic way. Then over and over, especially in recent years, many customers comes to recognize, even especially some professional data scientists come to realize the power of causality, the particular AI technology we have been using, and this is echoed with many experts and academic professors in the industry, and so this further strengthened our direction of going forward with this technology and this product.
Thank you. So I think we are coming to a close, but I would like to finish with talking a little bit about the future, because now we have talked about the past. So if you look ahead now, coming out of the whole COVID pandemic, and also with China opening up more and more. So if you look ahead for the next couple of years, what would you say are the big priorities for your company going forward?
Well, I'm pretty bullish, especially in the renewable energy sector. So far, China is the biggest, has the biggest or largest assets of solar power generation in the world. That's something like 300 gigawatts, and it's increasing fastly. And this trend, I think, is happening across the world, in US, in Europe, in Australia, and more renewable energy will be put into operation to replace the conventional coal-fired or gas-fired power generation. So I think that's a great trend. And also R&B is ambitious to develop internationally outside China. So that's why we have an office in Houston, Texas, in the US. because even US hasn't that big assets for solar. The building assets in US has much great potential to use our product because it has a high quality and robust data infrastructure. Yeah, I showed the typical data infrastructure in my, I think in my last 2 slides. And this is a very typical and commonly used database infrastructure in US customers. And simply said, IT and the software market, US has the best market for IT and the software. And it has been educated for many years to leverage the power of data.
Thank you. So I think that was a very timely finish because it's just past 6 p.m. But thank you so much, Glenn. And I'm sure that participants who have been impressed by you today and would like to get in touch with you can approach you. If not, they can certainly approach us at Venturous Group. And we are more than happy to make the introduction to Glenn and his company. So with that, thank you everyone who have participated today, and thank you in particular to you, Glenn. It was a pleasure to have you on this session today.
Thank you, Joanne, for having me today.